Welcome and good afternoon. Today we are to invite Professor Baker. Dr. Baker is an associate professor of economics and finance at Hunter College and the Graduate Center, CUNY. His background is in the field of law and economics, and he has studied how institutions, customs, and laws to change over time in response to changing environment and technology. His research has touched upon both theoretical and empirical aspects of institutional change and has found application in the changing nature of state law across the U.S. states and crosses societal variation in cultural practices. Dr. Baker's work has been published in leading economics and multidisciplinary journals, including the Journal of Political Economy, the Journal of Economic Growth, the Journal of Labor Economics, and Nature, Humanity, Social Sciences, Communication. He holds a PhD degree in economics from University of Connecticut. Please welcome Dr. Baker.
Thank you. All right, well, today I'm going to talk a little bit about, we'll talk about my joint work here with Jonathan Conning, a model of enclosures. Right? Use the mic. Okay. I'll try to use the mic. Well, yeah, maybe well, hopefully it'll work if I stand kind of like here. Well, I'll do my best. Anyways, okay, back to the subject here. You might see bucolic images, landscapes here, but to people like Jonathan and I, these maps are pictures of land that's been transformed to varying degrees, to individuated, I guess, ownership. And that's really what we're talking about here, right? The process by which land comes to be, goes from open access, anyone can use it, to more private ownership, private use, where outsiders can be excluded. Now, why might this interest you? Or, you know, it's kind of a sweeping thing to say, I guess, but why might this interest you? Well, it turns out that most important economic and historical epochs are accompanied by some sort of land transformation, some transformation in ownership. And so there are just a couple of big examples here. The first one, of course, is one that's interested me in the past, is I guess what you could call the first agricultural revolution, which was the process by which people switched from hunting and gathering as their primary mode of production towards agriculture, right? Growing crops and harvesting land, things like harvesting crops, things like that. So that's one example, and some of my past research has talked a little bit about that stuff. Of course, there's also the famous episode of the enclosure movement across England, right? That lasted close to 1,000 years. And this was the process by which plots all across England became, I guess, for want of a better word, more intensively farmed and more farmed according to private ownership. There's been hugely debated, and I'll talk a little bit about some of those debates as we somehow I keep springing ahead here as we move along. And of course, if I'm sort of to bracket that thing in the middle with our Jonathan and mine, our common interest, Jonathan has, I'm probably selling you a little bit short here, has done a lot of work on development and economic development, and this ongoing issue as to this ongoing almost policy issue about how should traditional property rights be treated in developing countries, and to what degree should we impose modernization or aid modernization. So what we're going to do is we're going to develop a very simple model which we think embodies some concepts which have been, I guess, not thoroughly treated in the literature, and use this model to cast lights on the hows and whys of enclosure, right? Why it happened, what it looks like when it does. And of course, we'll hopefully be able to shed a little bit of light on coincident phenomena, you know, or things such as inequality, right? When land becomes more privately owned, does it exacerbate inequality? Or does it seem like workers or labor is being exploited in this process, right? And those two things are related. So we'll talk a little bit about that stuff as well. Just to talk a little bit about one particular setting in which these debates have been, I guess, hashed out and rehashed out over the years. The English enclosure episode, right, has had kind of these two sides. and one of which I'm sort of borrowing some of Jonathan's vocabulary here. One way of viewing enclosures in this enclosure movement was from this Tory triumphalist perspective, right, which said, all right, well, as land was enclosed, it was critical to the whole development process of Great Britain, and of course, and then the ensuing industrial revolution. So this private property, development of private property on these previously sort of public common lands resulted in better incentives and more organized farming, which then led to productivity increasing, or increases in productivity. This allowed the industrial revolution to occur because you could feed a lot more people with a lot less land. And of course, here we are today, right? Maybe because of this process. Well, there's other people who I wouldn't say fundamentally disagree with that idea, but they say, well, yes, but at the same time, labor was expelled from the land, right? Labor came to be exploited in this process, right? Lower wages could be paid, and that wasn't so great, right? And people have even questioned whether or not there's this big bump in efficiency due to the enclosure process, right? Whether or not the existing conditions were efficient. And some have argued that, well, you know, it turns out when lands were enclosed and different forms of agricultural production were instituted, it didn't really create some giant bump in productivity. So hopefully we'll be able to comment on all of these things. And one of the things we'll hopefully be able to say about this debate is that, well, everybody, under certain circumstances, maybe everybody is a little bit correct here. Relatedly, and maybe if you're interested in development, or to maybe give this more of a policy twist and less of a primarily a topic of historical interest, some literature has, you know, there's been a lot of experimentation with trying to push developing countries towards property rights and enclosure and more private use of land. And it turns out that this does not always seem to give the productivity gains that people would expect. Right? It doesn't appear to be the giant winner that economic theory might suggest it is, right? So why might that be the case? And Ostrom, I guess I'm a little bit cut off here, is another person who sort of notes, well, a lot of times usage of common land is more efficient than you might expect, right? What about those possibilities? How does that interact with all of this? Okay. So what are the primary narratives describing the enclosure process? And the things that these are the big ideas, I guess, that we're going to take and run with in this work. And try to implement them. These are really the two components of this. So you may be familiar with the famous story of Alshane and Demsetz, which was this idea that, well, as population pressure grows on a particular, you know, in a particular locale, on a particular piece of land, well, this exacerbates externalities in use, right? The classic commons overuse problem. And so eventually what has to happen is somebody has to take control of the land, right, and regulate usage of it, right, by which is usually meant push people off until something like the marginal product of labor on that land is equilibrated with some wage, right? Use it more efficiently. Well, that's one sort of narrative describing why we might expect this, or one narrative of this enclosure process. Another is, I guess, a little bit less, I don't know if it's more optimistic in some sense, but maybe so. And it's just this idea that as population density rises, well, suddenly there's a lot more opportunities to do different things with your land, right? Oh, there's more people around. I can specialize in producing this product on my land to become much more efficient, right? If I own it and exclude others, maybe I can invest on it, and other people can do the same, and we can all sort of gain from that, right? So it's more of this technological progress story. That's a little rough, but I think that's about right. But there is this technological adoption aspect to enclosure, which I guess is embodied in this Bosarupian narrative. And there's also this optimization of use argument, which I guess is this Alshane and Demsetz approach more. And so we're going to try to build our model around these principles, but structure it in such a way so that it's a little bit easier to understand than the usual theory, which I'll sketch it for you kind of quickly, what it looks like. And as we go through the presentation, I will gradually kind of round out the ideas. So you might think about some of the classic work. Martin Weitzman had some classic papers on the subject. Demetsa and Gould had another exposition of enclosure and whether or not it was optimal from the perspective of society. And so they really describe the classic misallocation as one where common land is overused because people enter land until the average product is equal to, I guess, the cost of entry. Right. So the idea is that I can earn average product on any enclosed land there, right? Yet, if it's enclosed, what can happen is the encloser can then regulate access to the land and will essentially say, well, I'm going to keep people off my land, and the wage is this, I will hire people and put them and use them on my land until the marginal product is equal to this wage. And then if you sort of think about the closed system, right, there's people out there who can use land. It turns out what you have to do to hire them is pay them the marginal product or the average product, I'm sorry, that they could get on any unenclosed land. So you have this unenclosed land over here. People can earn average product. You have your land and you're trying to hire them. You have to pay them enough to entice them to work for you. And that means you have to pay them what they can earn elsewhere. And this is the classic source of the average product on common land equal to marginal product on enclosed land situation. So both Weitzman and Demetza and Gould analyzed this situation, but they don't allow for much else. So, for example, they don't allow that there's any sort of technological change across these different sorts of parcels. So they have some nifty results, right? One of which is that it seems as though labor can't win in this situation. That's right, isn't it, Jonathan? That if you were to enclose all the land, it strictly hurts labor, right? And so in that sense, enclosing land does appear to push down the earnings of your typical unit of labor. So it's interesting, but it's very hard to generalize the results from these models. They're not really well equipped to answer questions that we're sort of interested in and to how it actually looks when it happens. Right? If you were to describe what enclosure might look like, given the state of the economy or the state of affairs in a particular region, they're not so equipped to do that. I have this weird sentence here, not all that relatable to production economics. So what I mean by that is that we're used to thinking about, wages and rental rates on land and return to factors of production, right? And we like to discuss things, particularly when you're, in a more growthy sort of context. You like to discuss things like that. But it's very hard to see how these models relate to that, mainly because they're set up in this way where you have, you often have a couple of discrete sites at which production occurs, and the encloser can either shut off the site to everyone or not, right? And it's hard to sort of see, well, how the wealth of the economy, I'll say, for want of a better term, is distributed. And it's also hard to adapt to these different situations, right? If you wanted to think about different technologies used in enclosed land versus unenclosed land, it's hard to do. So this is kind of really this interesting, this last bullet point I might have put earlier in the presentation. And it's kind of one of the reasons, how Jonathan and I got rolling working on this. And it's kind of this interpretive issue. Everybody talks about common land and what it means and how it is, but what are we really talking about here? Are we talking about herders excluding farmers excluding herders from the land? Are we talking about hunter-gatherers and farmers, right, where people close off the land to outside access? Or are we just talking about traditional versus modern agriculture? And it seems like people variously import the logic of these models and use it in all of these different situations. But there's something a little bit different about all of them, and we're hoping to kind of put our finger on what it is and characterize that. Okay. So what we're going to do specifically is start off with this basic premise, right? This basic misallocation, right? And build a model that we can parameterize fairly easily, that we can relate to production economics. By what I mean by that is that we can sort of say things about how, we're going to have costly enclosure. We're going to allow some sort of technological change to occur or not as we move from an enclosed land to unenclosed land. We're going to think about population pressure. But what we'll get out of all of this is a pretty detailed qualitative picture of when we would expect enclosure to occur, what it looks like as it occurs, and we'll also be able to think about a little bit of the welfare and distributive impact of enclosures. Right, so we'll get all of these things out of this simple model. And so here's the basic setup. It's pretty easy to follow, and indeed that's a big part of the idea. first of all, we're going to start off with these two homogeneous production functions, right? Note to self, right here. Note how different this is. Well, the reason why I put that in there is because typically, I described for you very briefly the structure of the usual enclosure model, where you have a site and you enclose it or not. Well, that doesn't really suggest anything about what land is doing in the model, or what the other factors of production are, I'll say. Right? When you treat it like this, it's pretty clear that land is a factor of production, right? And you're now deciding whether or not you want to enclose and privatize, in effect, this factor of production. So we treat it like a productive input and not a site, right? And so this leads us to this understanding of what the returns to various resources are. So on enclosed land, for example, labor can earn its marginal product, right, which is the wage, right? It'll be paid a wage of its marginal product. Say it a little bit better. An encloser then will earn the rental rate on land, right? This marginal product of land in the enclosed sector. So if you wanted a backstory, we're sort of thinking about this as a situation where here I am, a particular, syndicate in charge of enclosing a parcel of land or not. And what I do is I enclose it and then I rent it, right? If not literally, figuratively, to an enclosed sector, thereby earning the marginal product of land. So it's a little bit different than enclose a site or not, right? And of course, with the homogeneous production function, constant returns to scale, this exhausts all of the input, all of the output produced on the land, right? It'll go to either the landowner or the laborer. And this is not typically a feature of how the typical model works. So on the unenclosed land, marginal labor will just earn its average product, right? Which has the advantage, once again, in that if you add up across all the units of labor that work on the commons or on the unenclosed land, well, that'll take care of all of that output too. So you can't quite see my inefficiency in equilibrium. Can I minimize this? I can try here. There we go, good. Okay, and so the inefficiency arises for the usual reasons here, is that labor is paying marginal product, right, on the enclosed land, right, which is equal to a wage, which has to be equal to the average product. Otherwise, nobody would work in the enclosed sector. Everybody would just stay in the unenclosed sector, right? And of course, this is inefficient because average product is typically greater than marginal product, right? And you'd like to, I'll show you in a second, marginal product, the marginal product should be equilibrated across the two uses. So here we have a little figure that kind of explains an aspect of this classic misallocation. If you think about it, from this axis is the amount of labor allocated to the commons, right? And so going left to right, we have labor in the enclosed sector, and going right to left, we have labor in the common sector, right? So if you pick like LE star here, that would mean this amount of labor is in the enclosed sector and this amount is in the common sector, right? And we have some fixed amount of land in each sector, which fixes the position of these curves. So as we increase labor in the enclosed sector, you can see marginal product is falling, as one would expect for a given fixed amount of land. In the common sector, same thing. As we increase labor in the common sector, you can see there's marginal product and there's average product, right? And of course, efficient use would be to equate the two marginal products across the two sectors. But in equilibrium, we get this here. Average product in the commons equal to marginal product in the enclosed sector. So this is the classic misallocation. We're at point B instead of point C, right? Too heavy usage of the commons, not enough usage, I guess the other side of that coin, not enough labor usage in the enclosed sector. And the deadweight loss there is that ABC triangle, right? So that's kind of the classic, I guess, Dumsetzian spurn on, well, not quite, but it's kind of the classic misallocation. I'll leave it at that. Okay, well, because we've made this, we've taken this extra step and assumed that the production functions are homogeneous, we can do a little bit of homogeneity Euler style mathematics and get a little bit further with those things here. So, for example, here's my unenclosed sector land. Because the production function is homogeneous, we can break it apart like this. right? Derivatives times the factors, right? That equals this. And so if we divide this through by labor, we wind up with marginal product plus this term over here, right? Now, this is an interesting, this affects for us an interesting little decomposition of what labor actually does when it's applied to the unenclosed or common sector. It says a unit of labor applied to the common sector gets its marginal product. Yes, a little dot there, I don't need that. But then marginal product plus marginal product of land times this thing here, which is the land share, right? So if you want to think about what happens when you decide to work a unit of labor, when you decide to apply a unit of labor to the commons, your labor does two things. It produces output, but it also claims a share of the land and the ensuing income from that land, right? So in that sense, you're using labor on the commons for two reasons, right? To claim land and to produce output. And we'll see as we move through the talk, and as hopefully I get to at the end of the talk, I'll have time to tell you, but this is often the key to understanding what, say, village institutions can do, or how policy can help, property rights policy, I'll say, can help rectify problems with perhaps inefficient enclosure. Right. So this is the dual role of common labor, we'll call it, right? Labor works and secures a proportional share of the land. So you can actually look at the graph and even see these two shares pretty straightforwardly in this, once you've enacted that or put in place this homogeneity or constant returns. So from here to here, this is sort of the wage, right? The marginal product of labor on the common land. And from here to here is the proportional share of the land income, the income generated by the land you've secured. And that'll, as I say, help us later. Okay, so we're going to go with a pretty simple parametric model here and hopefully get some more details. We're only going to think about an agricultural sector. In the paper, we've actually added a manufacturing sector, and it doesn't change things all that fundamentally. So we'll imagine that there's labor and land supply. Well, flip these around. Land and labor supply, T is land. That's our fixed amount of each. And of course, we can compute the ratio here is population density. Our common technology, right, will just be T to the 1 minus alpha, L to the alpha. Really the only thing, classic constant returns, Cobb-Douglas stuff here. We have this TFP parameter here, right? So we can allow this to be greater than 1. And we interpret this as relative TFP. So this is any bump we might get or not from moving from a common land to enclosed land, right? So that's possible TFP improvement. You might think about this as trying to embody the ideas of Bosera, right? When you privatize land, you can do something else with it. Okay. So one of the nice things about this is we can write from here on in, we can write everything in intensive form. And you can just think about, factor the setup like this. And in this way, you get shares, right? So the lowercase letters are the share of land enclosed and the share of labor that's in the enclosed sector as well. So we can just talk about everything in those terms, and then it'll turn out we'll be able to think about this as a population density parameter. Okay, so the first thing we'll do is we'll talk about the social planners problem and just think about if everything could be done perfectly, how would a social planner go about doing it, right? How much land would a social planner want to be enclosed? And we're going to first solve this problem, assuming that the social planner can also maximize or can also choose the correct labor allocation, right? So we'll follow that up with a situation in which they can't, and I'll sort of expound on that a little bit as well, and we'll see what it looks like. So just for future reference, it's also helpful to think about this as a two-stage problem, right? So first we choose labor, and then given some, that'll determine labor as a function of land share, and then we'll choose land share taking into account that the labor share adopts. So what'll happen, I think you can even just look at this equation, is you can see that when we take the derivative with respect to LE here, you wind up with the marginal product of labor and this here equal to this, right? And that will equalize these marginal products. And then really the question is when we're talking about enclosure, well, you can add some land here, right? But you remove some land here. And so what you're effectively doing, approximately, is you're getting a social marginal benefit from moving land from the common sector to the enclosed sector equal to this roughly increment, right? So that's, but you incur a cost to do so, right? And that'll become important in a second. So once we found this optimal labor share, we substituted in here. I kind of already said this, I guess, and then find the maximal or the welfare maximizing, output maximizing, same thing here, share of land enclosed. And so when we do this, right, with our parametric model, we get a pretty simple solution for labor here, right? And it really it has some kind of simple insights, I guess, that will become important later, especially when we compare it to things that happen in a decentralized situation. So as it happens, if theta is greater than or equal to 1, the planner, well, I should say strictly greater than 1, the planner will always use enclosed land more labor intensively than unenclosed land, right? So if you think about these as these ratios here, enclosed land is used more intensively. And it makes perfect sense why that's the case, right? It's the technology is better there. So you want to use more, right, if theta is greater than 1. So you want to use more of your labor in that sector. It's really almost that simple. So if we take that labor function, right, that I showed you here, and plug it back into our, parametric form of this function, we arrive at this. So this is our optimal enclosure function, and it's pretty simple. You can see that it has population density outside here, right, and it has this term in here, and if this, right, this thing right here is greater than 1 whenever theta is, and if this is greater than 1, well, then you can see this function just kind of is concave to the origin, right? So it just increases at a decreasing rate. And if you add a cost here, you find that we have just a concave down function. So what does this all mean here? Well, it means that you could say that the marginal benefit of enclosing land is always decreasing in this setting, right? So all you have to really do is think about, well, what is the marginal benefit to enclosing land? And you can check it at various endpoints to then get a qualitative description of the world here. So just an example, if we take the derivative of this with respect to TE, that gives us the marginal product, the social marginal benefit of enclosing. And if we compare it to cost, we can then decide or see if any land should be enclosed. So for example, if the marginal product is less than C at 0, right? Since it's always decreasing, it's never going to go above C. And this would indicate that we're never going to want to enclose land, right? By contrast, if we plug in a 1 there and we see that the marginal benefit is greater than C at 1, it means that we want, since it's always decreasing, we want to fully enclose all of the land. And of course, the intermediate case would be that we want to enclose some of it, but not all of it. And so this is kind of the picture here. The first thing I described, we don't want to enclose any, right? Here we'll enclose some land. And here we plot that function that I showed you, and we'll just enclose it all. So it's very simple, right? Now, if you take those z functions that like this condition, for example, you plug 0, right, in here after you take the derivative, you plug it in there. You can then just solve parametrically for L bar, population density, and you wind up with this locus, right? And basically it says, okay, here are the production parameters and the costs of enclosure. On this side, we have population density. If population density is less than this, well, then there will be no enclosure, right? Of course, you can flip the inequality the other way and say, well, if this isn't true, there'll be some enclosure, right? And you can then do the same exact thing for the case C prime greater than 1 and find when all land will be enclosed. And so at the end of the day, we get this picture that looks like this, right? Describing for us how enclosure relates to the parameters of the model. So here's relative TFP, that theta parameter, right? Here's the population density, and you can see that this is kind of like the Bosarupian story here, right? Like down here, we have low population density, and there isn't a big bump to enclosing land. And so in this circumstance, since enclosure is costly, we don't want to do any of it. But as population grows, right, it turns out that this bump to marginal product becomes more than worth the cost, and there's some enclosure. And of course, as we move to the upper right-hand side of the diagram, we get complete enclosure. Right? It's worth it to get the pump. Yes, sir.
Can you specify what is partial enclosure exactly? Like
Ah.
some land is enclosed and some is not.
Right, yes. So you would say that that is a circumstance in which something like this happens. And so here you see the percentage land enclosed, you'd see that something, half of the land would be enclosed. And that land would be hiring people at marginal product. Well, I guess in this case, it's the social optimum. And everybody else would work in the commons. Yes.
And I've been working on public access issues. with
Oh.
Roads,
Oh, okay.
the rights of way.
Uh-huh.
And out west, there's a lot of public land and you're talking about enclosure as a cost, right? From a physical fencing kind of
Right.
idea. But there's also kind of a lot of legal activity that attempts to restrict access to land through the fact that they threaten people with lawsuits. So I don't know, you might want to just think about that as an added thought.
Oh,
It's not just like physically going out there, but it's like if you cross my land.
right.
There's some big fights going on in Wyoming right now.
Interesting. Yeah, that's a, so we will have something to say about, whether or not, there's some sort of physical cost, I guess you could say, to enclosing land.
Right.
As a policy matter, would you want to augment that or not, right?
No, it's an interesting way to
no,
think about
it
costs.
is.
There's two different types of costs. One's a physical asset,
Yeah.
the other one's a legal prohibition, right, or some sort of.
Right, interesting, yes.
Can I just two more questions?
Yeah,
Sure.
two.
Yeah. For example, if 10% of the land is enclosed
Uh-huh.
and 90% of the land is enclosed, they both are partial enclosure.
Yes, you would say both of those are partial enclosures. So,
So we are going from nothing to everything.
well, no, here, what you'd say, I guess we could have added some detail here. Maybe we could shade it. You could shade this from 0 to 100%,
Okay.
right? So as you move left to right, yeah, there's more enclosure. That's actually
And the other thing is, when you are taking this model, are you considering time? Like, for example, if production is function of time.
no, but I'll have something to say that this is purely static model, right? One shot, but I'll have something to say about that. And, in some sense, you might think about what we've done here. We wound up writing a whole paper on sort of the basics of what we thought were going to be the actual papers. So there's some things that, I'll talk a little bit about there.
It's
Yes.
kind of like marginal input enclosed might be
Oh, sorry.
going according to time.
Oh, I see what you mean.
Production or something like that.
Yeah, I think I'll have some stuff some things to say about that. That's certainly a big part of this. When you enclose, you might, our parameter here is pretty simple. But that might be one thing that you get when you enclose land, is you might say, well, now I can plant something on it. I'm not worried about someone else tramping the land and taking my output. So I can use a longer planning horizon on this land, right? Might fold that into technology. I don't know if that's satisfactory, but hopefully we'll come back to that towards the end. Yes.
Would you move back a couple of slides
Mhm.
that shows the optimization? Yes, but just the one. No, just
Right here?
No, just so
Here?
no, just the one that is just maximization or the function.
Mhm.
What well, in that the objective functions are. Well, I'm just wondering if the setting some constraint is necessary to solve the problem, say, alpha should be less than 1 or something like that.
Oh, okay, yeah, alpha is between 0 and 1. Definitely, yeah, that so you have to sort of think about alpha here as the typical, it could be 0.5 or something, but it's between 0 and 1, right? The factor intensity parameter. Yeah, and we have assumed it's the same across the two sectors. That's, it turns out that most of these results go through without any particular parametric form, but it's easiest to follow here. Yes.
Sorry, Professor, I just because I'm not familiar to the land literature, but it seems to me that because you quoted the two papers, right, the real ones, right? I'm just wondering because maybe in the past there were no buildings, but now you were to enclose the land and you build a building. That means that land's productivity, that land's area increases 20-fold. Maybe they build a building with 20 floors, right? So how does that, because that doesn't factor into this model, because you just do the gradient roughly steeper, but if you build a building with many floors.
Okay.
Like that means that, so I'm just asking, like, in this literature, are the assumptions that realistic?
Okay, I would say, yeah, if you're talking about while we are talking about the sweep of history here, right, going back, say, 10,000 years, maybe, we probably haven't gotten to the skyscraper era yet. I mean, but one thing you might do is I haven't thought of this, I've thought about this in other settings, is you might include some sort of cost of bringing land into the commons, right? So maybe there's an elastic supply of land. That might be something like what you're saying, but that could be generically true of any, investment that you might make. It doesn't have to be, building like that.
But crudely, the theta would do the same function.
I think so.
Which you just say it augments land,
Yeah.
it's gonna look the same.
So that was kind of our thought, was that anything that augments land, its productivity, whatever, we're folding it all into theta. That was the best answer there.
Historically, were there any like requirements on land size? Like, was there like I'm kind of thinking of like the continuous choices.
Yeah. Okay. No, that's a good point. So I think that's probably the case, that there's always been a minimum scale that you can't certainly enclose, a 1 inch square of land. So I guess, that's an approximation, we would have to say.
But often this could be squatting, right? This could be squatting and setting up a fence.
Right.
Yeah, well, the US Western had there's a whole thing about proving up your land, if you will. If you went out west, there was a standard size. They had like a knockout size of a block. I can show it to you. And then you would stay on it for 7 years, essentially as not a legal squatter. And then you could prove up your land if you showed that you were done certain things.
Right.
And
So
the whole history of Western land.
So it's fascinating. Yeah. And it's also, I don't know if we had those cases in mind, but it's certainly interesting to think about, it's.
The governments are the size. I really thought about why they set the size they did. Maybe it was based on the land out there was a certain productivity.
Yeah, good. Interesting to think about.
I guess you're right. You can add that as an extension later on of
Yeah.
something of like there's a cost for choosing land size, and then with
Yeah, that sounds like my original paper, but it's interesting. No, I hadn't, but not in a modern context like this. So let me keep moving here. I don't know how I'm doing on time. Am I
Still, you have 15 minutes.
15? 15. All right. I gotta get moving here. Okay. Anyway, so we could also think about this maybe from a more Alshane and Demsetzian perspective, right? And in this case, what we want to do is we can imagine that, we can enclose land, but we can't fiddle with this APL. We can't fiddle with this average product equal marginal product thing. So this gives us this impetus for enclosure, right? That says, well, when we enclose land, now we can do the marginal product thing, and we can get, this is a reason for imposing, is that we can now make usage more efficient on the enclosed land. We couldn't do that before, but by assumption, by the virtue of using the first best optimum. So in any case, we solve out everything, and we get this as the optimal function describing labor allocation. And you'll see here, now we have this parameter lambda, which is a little bit different than this one here, right? Which is bigger, right? So one thing that's interesting about this modified parameter, right, is that it can still be greater than 1. We can still have theta greater than 1, but we can also have this be true, right? And why is this important? Well, because this can be less than 1, right? And when this is less than 1, this whole labor allocation function is no longer nice and concave, but it can be convex, right? And that changes just about everything, right? And that embodies a certain sort of, I guess, feature of the commons, which may lead to undesirable outcomes, right? So one thing you can't do is if you have a convex function, you can no longer check derivatives, right? As we did before, because you can't say, well, marginal product is decreasing, right? It's possible it isn't. It's possible it's increasing. Another possibility is that labor winds up being used less intensively on enclosed land. And this is something like labor expulsion. You enclose land, and instead of saying, oh, I have this new technology, I'm going to hire workers, you say, I'm enclosing this land, get off of it so I can use it more efficiently. Well, as a consequence, when you push people off your land, you push them into the commons, right? When you push them into the commons, it gets even worse. As the commons gets worse, the wage that you have to hire people goes down, right? So then maybe you hire more people and close more land, and you get this cycle of expulsion and exacerbation of the commons, all because of this simple change in that lambda parameter. So what are the implications for the social optimum? Well, full enclosure, you see here now we have this red line, and it says basically that if you sort of ignore the blue here, below the red line, no enclosure is optimum. Above it, full enclosure is optimum. So long as our theta is in this range, we either want no enclosure or entire enclosure, full enclosure, right? So over here, of course, we get we get sort of a narrowing of the intermediate range, but down here we have no enclosure, in here some enclosure, and up here full enclosure, right? When we sort of parse out all of the possibilities that result because of that parameter. And of course, you know, we can no longer check derivatives here. You have to kind of check the function endpoints as well. And I'll get into that a little bit. So this might be more of the Alshane and Demsetzian story and what it looks like, right? What happens when we're enacting enclosure to control a commons problem. Okay, so what about decentralized enclosure processes? I'll try to move through this with a little bit of speed here. Well, here we just imagine that a particular entity, we're a little bit vague about who it is. The syndicate in charge of a piece of property, a small piece, can enclose it at cost C or not, right? And then what they do is they can exclude anybody from using the land, that they can exclude people from using it. They don't have to pay any compensation. But what they then do, you can think about it this way, is rent it or lease it to the enclosed sector and thereby earn the rental rate on land, right, as their returns from enclosure. So this suggests that enclosed land will pay WE here, the marginal product, and land will get the marginal product of land in that enclosed sector. And of course, this exhausts output. So really all you do is compare the expected return to the enclosure cost in this setting. And the equilibrium concept here is just an aggregative game, like we talked about in 702, right? So all these individual atomistic players do is they sort of say, well, when I want to decide whether to enclose or not, I just look at what the enclosure rate is, and I think about what the implied rental rate is, and then decide if it's greater than the costs, I'll do it. So we have this as our labor allocation now. If I use our parametric model, we get this as our rental rate. If I plug this into here, right, you can see we kind of cancel out the TEs and we're left with this as an expression for the rental rate. Now, once again, based on this lambda, if it's greater than or less than 1, this function is qualitatively very different, right? If lambda is less than 1, it's convex, right? So in other words, the rental rate on land increases as more people enclose, right? If it's greater than 1, well, then it has a concave shape. So, and that's more the standard case I would think of, right? As you enclose land, you're sort of providing more of a factor, and it has the usual properties. The marginal product goes down, right? So the fact that this rate of return can be increasing or decreasing changes everything. In particular, when it's potentially increasing, we can get corner solutions and sudden flips. And, like I say, that's not you usually think about the factor of production as you increase the amount of it that's in use, the marginal product should go down. So here I kind of summarize all those properties, as I said here about the lambda thing. And this lambda less than 1, I already described what it does for labor. Well, if you translate that through to the rental rate on land, that implies that more enclosure increases the rental rate on land. So we get crowding and lower wages and all of these things going along with that. But if you're an encloser, it means your decision, there's a strategic complementarity there. If we all enclose, we get a high interest rate, perhaps. If none of us do, well, rental rate. None of us do, then the rental rate stays low. So, I mean, I guess I could walk us through all these cases, but maybe it's easiest to just show you what the picture looks like. So this is the situation we get out of this decentralized case where everybody makes independent enclosure decisions. So Over here, we have no enclosure on the lower part of the diagram. Up here is full enclosure. Partial enclosure over here, but as we move to the left here, where that function becomes, the rental rate becomes increasing and the labor function is convex, we get multiplicity. And so in this shaded region, we could have all full enclosure or no enclosure, nothing in between. Now, this dashed line here, you've guessed it, I've used a solution to for equilibrium selection. I've used the global games, or Jonathan and I, to pick out the equilibria there. So you could, just to give us a unique equilibrium, and you might say below this line, no enclosure, above it, full, right? So it's a pretty different, you get some interesting things based on this, whether or not we're in this lower TFP region where theta is less than 1 over alpha, or the high TFP region. So are private enclosure decisions efficient? Well, you know, I kind of say some things about it here, but maybe it's easiest to just sort of slap the two pictures on top of each other. And you can see that, well, I mean, maybe the first thing to say is that there's a whole region of the parameter space where there's no enclosure and it's efficient. And there's a whole region of the space up here where there's full enclosure and it's efficient. But there's also regions where, for example, if I pick a point like this suggests that there will be full enclosure when the optimum would suggest that there be none, right? And so you can even get enclosure up here, right, where you have full enclosure, even though there's technological regress, right? Theta is less than 1. So this is kind of the trouble region. Over here, you might say, well, you know, we would like to have some enclosure, but we don't get any. But it's more a question of degree, I might say, right? Rather than stark qualitative differences based on the two sides of the graph here. Okay, so if I were to sort of think back to the very first slide here where we talked about, you know, people who said, well, is enclosure bad for workers? Is it exploitative? Does it depress wages? Or does it allow better technologies? It really depends upon where you want to put yourself in the parameter space, right? Over here, right, where the functions are concave, the rental rate is decreasing in the amount of enclosure. That's kind of the triumphalist story, right? That, well, yes, better technology is good. We can suck some land off the commons. We'll use more, it'll be used more intensively on our enclosed land. That's good. Over here, the story is kind of different, right? You enclose the land and expel the labor, wages go down. And it looks a little bit more like the I guess, for want of a better word, the Marxian description, exploitative description of the commons. So everybody's right for some value of the parameters. It turns out that if you wanted to compare income shares, land and wage shares, you can do that. And indeed, that also maps into this space. So labor loses and land gains in the low TFP region here. And the opposite is true in the high TFP world. So how am I doing now? What do I got?
348.
Oh, really? That's not bad. It's 12 minutes, right? I guess I kind of caught up, so I can kind of slow down for this interesting part here. What we might want to do now is back up a little bit and think about what sorts of solutions we might what we might enact to get this picture, get the orange area on this picture to look more like the blue area, right? And this, now we're sort of moving into this realm where we're trying to understand maybe what village institutions do, or we're trying to understand what sorts of policies we might use to mitigate commons problems, right? And what I mean by policies is certain sorts of compensation mechanisms that might exist, like payment for enclosure to affected parties, things like that. So if we take our total output function here, right, and we differentiate this with respect to TE, remembering that LE is also a function of TE, right? We get something like this. So we have the derivative of this, which is the marginal product of land, of enclosed land. Here's the cost of enclosure. We have, oh, I need a pointer here. We have the lost marginal product of commons land, but then we also have this labor shifting effect, right? As we enclose land, we shift labor from the common sector to the enclosed sector. And so that's another external benefit. And so one way of thinking about why the divergence happens here between private and social goals is that the private encloser just thinks about this, right? This is the rental rate on enclosed land, and this is the cost of enclosing it. And they don't consider the loss here or this labor shifting potential benefit. So the question then becomes, what sorts of policies could you put in place to do that? So what I'm going to do is bring us back to this Euler decomposition here, right, where we divided through by LC. And we're going to sort of remember that labor applied to the commons has this dual purpose, right? It secures some of the land for you, and it also creates output, right? And really the key to part of the policy implications, or part of what village institutions might do, is you uncouple these two things. So what we're going to do is we're going to suppose that we have some parameter here, mu, which captures the degree to which, think about it this way, you're a traditional user of the commons, and maybe there's some village institution that says, Baker is used, typically worked on the commons 3 days every week. That means he in effect has a, certain share of the land. If he decides to go work somewhere else, we're still going to give him some compensation, or he'll still be able to get some recompense for that share that his labor has secured. So we're disconnecting those two functions. And we're using it according to this parameter mu, where mu measures the degree to which I can leave the commons, yet still retain those implied land rights. So what does that do to the decomposition here? Well, I put my 1 minus mu here. That means that if mu is equal to 1, I don't give up my land income, right? And so you can see what happens. Mu equal to 1 zeroes this out, and look what happens to the marginal products. They're suddenly equal in the on the unenclosed land and the enclosed land, right? So strangely, or maybe not strangely, we have the misallocation with mu equals 0, right? I don't want to leave the commons. I want to work it too extensively because that's securing my land share. We get rid of that, suddenly labor is free to allocate, right, optimally across the two. So we solve labor allocations by maybe having better definition of, traditional property rights, if you want to think about it that way. You might even think about that as a policy ramification. So labor allocations go from the classic misallocation to first best optimal as we let this parameter go from 0 to 1. So I'm also going to introduce this tau parameter, which is the degree to which we have someone who encloses land has to pay the current owners of the commons, right? So you can think about it this way. We have this mechanism by which if I'm working the commons, I can leave it and still retain my land share. But we now have a mechanism, if anybody encloses the land, they have to pay us, the people who use the commons, for doing so. And that's this, we make that proportional to this external cost. So we call that tau. And of course, tau equal mu balances the budget. I enclose, I pay tau to the group. What the group then does is takes it and chops it up according to the shares here, and that will, square everything. So what happens when we do this, right? Well, we have a couple of pictures. Here's my original picture where there's no compensation at all and no formalization of rights. Here's what happens if we just do the village right thing, but without any compensation paid by enclosers. You can see what happens is it's increased my incentives to enclose my land. Why does this happen? Well, now the allocation of labor is efficient, right? There's less labor allocated to the commons in general. So what I can do, what that does is it pushes down the wage I have to pay to enclose the land or to hire workers, and thereby makes enclosure more desirable. So in that sense, maybe through an unexpected channel, we've gotten more enclosure by, sort of disconnecting the dual role of labor there. If we just have compensation paid, you can see that now we've kind of swung way too far in the other direction. So now nobody really wants to enclose at all. And we've solved a lot of those problems where we had the ugly outcomes up here of technological regress. But now it's really hard to get any enclosure, right? And so that's not great either. But if we have both, I mean, lo and behold, we get these two things sort of perfectly coinciding, right? And it kind of solves all of the problems. Once again, the labor allocation problem is solved by delineating or uncoupling those two aspects of the labor allocation, and then outside compensation fixes the overing or the enclosure decision. So it's kind of a neat little way to think about these policy through this. Enabled, of course, by our use of this more conventional production and constant returns. Okay, so we haven't talked, and there's some certain second order problems that might fall into this category as well. So, this, what I mean by this is, if people know ahead of time that we're going to, take their labor share and use that to delineate land rights, well, that might cause some sort of people to rush into the commons, things like that. So there are some other, like with any policy, there are problems of that nature. So just in conclusion, does enclosure improve welfare for everyone or does it hurt labor? The answer is yes. Right? It depends on how you configure the parameters. Right? So does enclosure occur too frequently or too seldomly? Yes, it could be either way, right? Depends once again on whether you think you're in this high TFP or low TFP world. So one thing that sort of excited us was that, we did get these interesting policies that were based on different notions of ownership that immediately sort of come to your mind. And like I said, I think at the beginning or maybe halfway through the talk, we sort of started this project with other things in mind, like thinking about structural transformation and dynamics and all of those things, and then decided that we had to first get all the static math in order. And that's kind of what we've done here. And I think the results were a little bit richer and more interesting than we could have hoped. Yes.
I think that there will be no problem to replace the land with the capital, and you can make another story like.
Oh, okay.
The labor is the worker.
Yep.
Construction worker.
So
you have the capital means that you become a member of the union.
right.
So then they offers you.
Oh, I see. Oh, geez.
Like the equipments, heavy equipments for the insurance, and then you need to pay the union membership, right?
Oh, I
You
see.
can make another story, but the structures are exactly. the same.
Oh, okay. Oh, that'd be neat. Yeah. Right. So I guess how did I do on time? I think I'm gonna wrap it up there.
Yeah, it's time to wrap it up.
Oh, okay, good. Did I go over?
Yes, please.
No.
Yeah, yes, it's time to wrap it up. So, I thank you for just sharing your.
Sure thing. Yeah, no, it was a thank you for coming and listening.
I'm sure all the students are very much satisfied by your research study. Well, next time the professors, Matthew, Megler will present.
Oh.
well,
You're up next, huh?
research paper. Well, if you have any questions, feel free to raise your hand.
And I can hang around too and talk more informally if you'd like that.
Well, Dr. Pilas, what, do you have any announcement?
Yeah, I just want to announce it again. I'll be having a data seminar and we'll be bringing in different data sets that are available to you. I think I'll schedule it around this time on Fridays or alternate Fridays. So I'll send out more information again. I'll probably start with Bureau of Labor Statistics data, which if you haven't used that, it's a free and available resource that could be very useful for a lot of different studies. There's also a longitudinal employment and household dynamics data, which is a fascinating data set and also be really useful. Right? Thank you.
Oh, great. Thanks.
Thank you very much.
Sure. Can I stop the Zoom here?
Yes. Let me ask you.
In the western, so again, I guess they